We are Arctic Autonomy and we designed an off-grid vaccine cooler.
Vaccines save lives, but sometimes those lives are way the heck out there in the middle of nowhere. In order to fix this problem, we created this prototype, a box that keeps the vaccines cold, a battery that powers all the functionality of the box. The box is comprised of polystyrene insulation and this nice acrylic finish. Inside the box is a Peltier device which transports the heat from inside the box outside the box. In order to make this project work, we need to maintain a temperature of less than 32 degrees Fahrenheit for 24 hours. Now, this battery can almost do that. It can achieve the temperature, but not for as long as we need it. If only we had some more money.
All right, to kick us off, we're going to start with our basic structure of our cooler assembly. Over here on my right, I'm going to have the power source attached with a transformer. Coming over to the actual cooler itself, our structure is going to be made of acrylic, as you can see on the outside. That was all cut with a laser cutter to the CAD specifications that will be outlined in the final report. Looking on the front here, we're going to have an LCD box with our basic LCD controls. That's going to actually control the inside of the cooler assembly. On the side here, we're going to have our relay box on the top, and then on the bottom we're going to have our Arduino box. Each of these is going to be a structure and a case to hold all the circuitry. On top you can see the Peltier assembly. On top is going to be the cooler, and inside the actual cooler itself, under the lid, we're going to have the Peltier. On the inside is going to be a foam structure. Styrofoam itself is all cut to specification as outlined in the final report as well, based on the SolidWorks drawings. The fan is mounted by these 4 pucks on top of the lid, and then inside we're going to have a 3D printed 5-hole vaccine vial holder.
So for our cooler, we use a Peltier to cool it down. We've got a heatsink on this side with a fan to get the air circulated across that. And on the heat side, the hot side, we have a similar setup. We can see a heatsink and a larger fan to keep the heatsink at ambient air temperatures. For our Peltier, we found out that there is an optimal operating range, which for this Peltier is 12 volts, 3.5 amps. Right now we're running at 3.7 amps, 11.5 volts. Unfortunately, just due to the limitations of our budget, we weren't able to get a better transformer that could get the voltage and amperage that we need. So we're not operating at the optimal temperatures. With these settings, we get a temperature differential of 40 degrees Celsius, but if we were able to get the right settings, we could get a temperature differential of 80 degrees Celsius outlined in sheets in our data.
Next, we will talk about the circuitry of our Peltier device. So we have the fan at the top and a fan on the inside also, which are connected to a relay that is seen on the side of the box, and then we have the Peltier connected to a different relay, and those are powered by the battery. The Peltier runs through this transformer device, so we are able to change the amperage and voltage going to it. Our LCD screen and buttons and buzzer also are connected to the Arduino that is in this lower box right here. And we have a ton of wires in there that wire the different components, so we are able to run the components through the Arduino and through the code.
The coding for our fridge is quite simple. It is a bang-bang controller that controls these 2 relays. The fans are always on. The Peltier goes on and off based on the temperature that is read out here by a thermistor within. And the code reads the temperature, sees what the difference between the temperature and the set point is, decides if it needs to turn on the Peltier, reads out warnings, and repeats that until the end of time. The buzzer is not currently on because we would not be able to hear us over it, but the buzzer is one of the warning systems. It's just not on currently.
Okay, I'm going to talk about some improvements that we can put in our design. So as Nate previously mentioned, our transformer isn't the best. It's not able to maintain and reach the ideal voltage and amperage that is needed. And our battery can also be better. So it is able to reach 32 degrees Fahrenheit, which is our freezing temperature, but it isn't able to maintain it for 24 hours. A bigger battery would be needed to do that. And we can also get better Peltier devices. These are a little bit cheaper, so they're not as efficient as more expensive ones would be. And then, since this is just an initial prototype, we can also create something that houses both the cooler and the battery and not have them as 2 separate systems.
In totality, this prototype can get in any car and go any distance, and hopefully save some lives.